Have you ever wondered what's actually happening inside your head when you fall head over heels in love? That feeling, it's powerful, sometimes confusing, maybe even a little overwhelming. It can feel like your world is tilted on its axis. And then, as a relationship deepens, there's that sense of comfort, of knowing someone gets you, of feeling safer just because they're around. But relationships aren't always smooth sailing, are they? What about those arguments? Especially the ones that seem to reappear, like a scratched record, even when everything else feels good. It turns out, these profound experiences aren't just abstract emotions floating in the ether. Neuroscience and psychology have mapped out tangible changes in our brains, revealing how love, attachment, and even conflict sculpt our neural pathways. Let's explore some of what science has uncovered about the brain and love. When you first fall for someone, it often feels like a rush, an intoxicating blend of excitement and focus. A key player here is dopamine. Brain imaging studies, like those pioneered by researchers such as Helen Fisher, have shown increased activity in areas rich in dopamine when people view images of their romantic partners. Specifically, regions like the ventral tegmental area, VTA, and the caudate nucleus light up. These are core parts of the brain's reward system, the same system activated by highly motivating experiences. This dopamine surge contributes significantly to that feeling of exhilaration, intense focus on the loved one, and the drive to be near them. It provides that powerful sense of reward simply from thinking about or being with the person. But it's not just about the initial thrill. As feelings deepen, other neurochemicals step into the spotlight, crucial for building bonds. Oxytocin, often nicknamed the bonding hormone, increases during moments of closeness, like hugging, touching, or intimacy. It fosters feelings of trust, connection, and calmness. Similarly, vasopressin plays a role, particularly linked in some studies to pair bonding behaviors and long-term attachment, showing variations in its influence between sexes in some animal models. Together, these hormones help cement the emotional glue that holds partners together, transforming initial attraction into a deeper connection. Interestingly, falling in love seems to dial down our brain's natural alarm system. Research suggests reduced activity in the amygdala, a brain region heavily involved in processing fear, threat, and negative emotions. This dampening effect might contribute to the feeling of safety and security we often experience with a partner, allowing us to lower our guard and build trust, perhaps even overlooking some initial red flags. There's also evidence suggesting shifts in serotonin levels, particularly in the early, intense stages of romantic love. Some findings indicate that serotonin levels might temporarily decrease, mirroring patterns sometimes observed in individuals with obsessive, compulsive disorder. This could potentially contribute to the preoccupation, the intrusive thoughts about the loved one, that feeling of being utterly consumed by the new relationship. It's part of why early love can feel so all-encompassing, maybe even a bit crazy. And while love often brings comfort, the very beginning can be, well, stressful. The uncertainty, the excitement, the vulnerability, this can lead to an initial increase in cortisol, the body's main stress hormone. However, as the relationship stabilizes and feelings of security grow, cortisol levels typically tend to decrease in the context of the relationship, contributing to long-term well-being. As love matures beyond the initial stages, the brain continues to adapt. One fascinating area is pain perception. Studies, including one from Stanford University, have indicated that focusing on a loved one, even just looking at their picture, can activate brain regions involved in managing pain, potentially reducing the subjective experience of physical discomfort. It seems the presence or thought of a partner can tap into our natural analgesia systems. Furthermore, secure, long-term relationships appear to foster better emotional regulation. When faced with stress, individuals in supportive partnerships often show more buffered physiological responses, like more stable heart rates or lower blood pressure reactivity. The partner becomes a source of co-regulation, helping to calm the nervous system. This suggests that a loving relationship can contribute to resilience over time. Love also seems to literally change our sense of self through neuroplasticity, the brain's ability to reorganize itself. The concept of self-expansion suggests that as we bond with a partner, we begin to integrate aspects of them, their perspectives, interests, resources into our own self-concept. Our identity subtly shifts and grows through the relationship, reflecting changes in neural pathways associated with self-representation. Of course, how we experience love is also deeply influenced by our individual histories, particularly our attachment styles, whether we tend to be secure, anxious, or avoidant in relationships. These patterns, often formed in early life, correlate with different brain activation patterns during relationship-relevant situations. For instance, individuals with more anxious attachment styles might show heightened amygdala reactivity when perceiving potential threats to the relationship, reflecting a greater fear of abandonment or rejection. A healthy, supportive relationship generally correlates with positive health outcomes, potentially including aspects of immune function. The reduced chronic stress and increased social support might contribute to better immune responses. Conversely, relationships marked by high conflict and stress can have the opposite effect, potentially contributing to chronic inflammation and suppressed immune function due to prolonged cortisol exposure. This brings us to those recurring fights. Even in largely happy relationships, repetitive conflicts can take a toll, and neuroscience offers insights into why they're so sticky. When the same argument erupts repeatedly, the amygdala can become sensitized to the specific triggers of that conflict. It learns the pattern. Your brain might start anticipating a fight, triggering a threat response, that fight or flight feeling more quickly and intensely each time, even if the situation isn't objectively that severe. It's like the brain shouts, "Here we go again," and jumps straight to high alert. This cycle creates inconsistency. Your brain receives conflicting signals. The relationship feels safe and loving, promoting oxytocin release, but then this specific interaction feels threatening, triggering the amygdala and cortisol. This dissonance can subtly erode the deep-seated feeling of trust and security, even if you consciously still love and trust your partner. It's confusing for the brain's bonding systems. Navigating these repeated conflicts is also taxing for the prefrontal cortex, the brain region responsible for higher-level thinking like planning, impulse control, empathy, and rational decision-making. Constantly trying to predict, manage, avoid, or resolve the same unsolvable seeming argument is mentally exhausting. Over time, this can lead to executive function fatigue during conflicts, making it harder to think clearly, empathize, or break out of automatic, reactive patterns. You might just feel overwhelmed, numb, or shut down. Crucially, every time the argument plays out in the same way, it reinforces the specific neural pathways associated with that negative pattern. The triggers, the emotional reactions, the defensive responses, they become more ingrained, more automatic. It's like carving a deeper groove in your brain, making the pattern harder to escape without conscious, deliberate effort to create new pathways, new ways of interacting during those moments. The recurring spikes in cortisol associated with these unresolved conflicts also contribute to chronic stress, potentially impacting sleep, mood, and physical health over the long term. Understanding these brain processes doesn't diminish the profound personal experience of love. Instead, it highlights just how deeply relationships shape us, right down to our neurobiology. From the euphoric dopamine rush of new love and the bonding power of oxytocin, to the calming effects of a secure partnership and the neurological challenges posed by recurring conflict, our brains are constantly adapting, learning, and responding to the people we connect with most closely. Recognizing these underpinnings can offer a new perspective, fostering empathy for ourselves and our partners as we navigate the beautiful, complex landscape of love and connection.